Sabah al Khair students, my name is Arwa and tutorial name is AB Tutorials Learn Hard. So we are in series of dimensional analysis. Right now we are learning uses of dimensional analysis. What are the uses? In part 1 I told you about how dimensional analysis we can get SI units, we can switch from one system to another system. In part 1 and part 2 the same concept we did numericals, and the process is going on. And here is error connection, which is another very important use of dimensional formula. So let's have a quick example of it. Let's say we have a formula t equals to 2 pi under root of LG. So now look, here is time, here is length, and here is acceleration due to gravity. Equal to means the dimension on one side must be equals to dimension on other side, or SI unit of this is equals to SI unit of this. Okay, if this formula works well, it means the dimensional formula of both sides, LHS as well as RHS, must be equal. If not, it means this formula is incorrect. Let's check out. In LHS we have T. T means time, correct? So dimensional formula, it shows with capital T, and SI unit is seconds, correct? L represents here length and G is acceleration due to gravity. Now let's go towards the RHS. RHS has 2 pi under root of L means capital L. L means length, that is denoted by dimensional formula capital L, and acceleration due to gravity. G is acceleration due to gravity. It means it is acceleration. Right, we know that acceleration is velocity upon time. Velocity upon time means since it is constant, acceleration due to gravity is constant, but it is acceleration, so it has same dimensional formula L upon T2. I am right, L upon T2. We derived this in our previous video and in part 1. Okay, so if you kindly check part 1 and part 2, it will be very good for you. Okay, so G is equals to, can I write L upon T2 instead of it, dimensional formula? So 2 pi, L to L cancel, and T will go to numerator, right? Okay, that is 2 pi T. Since 2 pi is constant, it is just a number. 2 is number, pi is number, only T we need. So we are left with 2 pi into capital T. T means time. So can I write only T? And in LHS also it is T. LHS we left with T, and RHS also we end up in T, and of course standard unit is seconds. So it means this formula works well. Okay, this formula is correct. Let's check out another formula. Question number, that is 1, let's say it is 2. So we have velocity is equals to 1 upon length under root of P. P denotes here pressure, and P is pressure, and this is rho. What this P is? Look, P is pressure, rho is density, L is length. Okay, pressure, density, and length, and V is velocity. So we have relations. First LHS. LHS we have V. V is displacement upon time, or displacement will be dimensional form. In terms of dimensional formula, we have displacement L and time T. Okay, so V is equals to LT minus, can I write SI unit of it? Yes, length will be meter and T will be seconds, correct? So can I write meter second inverse or meter per second, right? Let's go towards the RHS. What is RHS? RHS, they have given us 1 upon length under root of P and rho. So let's, length is equals to capital L, length, dimension formula we have capital L, under root pressure. Oh, pressure. What is pressure? Pressure is your force per unit area. Force is mass into acceleration. Area is length into length. Remember, we have to end up in MLT form. So m is the mass, acceleration is L upon T2 into these two L. So L to L cancel, and m, since it will go to numerator, so L minus 1 and T will be minus 2. So a pressure we can write in MLT form in this way. Similarly, in denominator we have rho. Rho means density, and density is mass per unit volume. Mass per unit volume. M, L means L cube. Remember, okay, fine, sorry. L into N, that is N upon L cube, or M L minus 3. Correct? So may I write, instead of P, I can write it in terms of ML minus 1 T minus 2, correct? And rho, can I write rho like this, ML minus 3? Okay, so my whole formula is now in dimensional, changes to dimensional formula. That is, can I directly cancel out m to m? Okay, and in numerator we have L minus 2, T minus 2, and in denominator I am left with L minus cube. Okay, so 1 upon L is equals to L minus 1, T minus 2, L to the power plus 3. If this denominator goes to numerator, it will be plus 3. Okay, so 1 upon L under root plus 3, L minus 1 plus 3, T to the power minus 2. So 1 upon L under root L square T minus 2. Correct? Can I write it like 1 upon L under root L square upon T square? So now you find it, L and T or 2 cancel. So we are left with 1 upon L under root of L upon T. Oh sorry, not under root. Under root is cancelled now. So cancel, L to L cancel, so we are left with T, or we are left with T or T inverse, and in SI unit is second, TSI unit is second inverse. And look, our RHS is meter per second, or LT minus 1, and means in our RHS we have LT minus 1, and in our LHS we have T inverse, so it means this doesn't equal. So this formula which you are trying to make, you are comparing velocity with this, is totally incorrect. Okay, and this formula you find it if you write, this is time. We can't imagine time in terms of such a big formula, where we don't have even, in RHS we have time, and LHS we don't have time even, but still these two are equal. Why these two are equal? Because their dimensional formula are equal. That's why this is consistent formula. This formula is correct, but second one is not correct. Now question number 3. This question number 2 and question number 3. Question number 3 asked in cbse 2009, and they have given VA is equals to A sine 2 pi T pi capital T, and this is equation 1, and second equation they had given A sine VT. So they asked for the displacement y, that given this y is the displacement, particle is going under periodic motion. Rule out the wrong formula on the basis of dimensions. Symbols have standard meaning. What does it mean? It means y is showing here displacement. Okay, this t and this t and t is showing time. Okay, capital T time period. T is also time, small t is time. Okay, what is v? V is velocity, and this small a represents amplitude. Okay, so let's check out which one is correct and which one is not, which one can be a formula and which cannot be. So let's check out equation 1. Equation 1 in LHS, equation 1 is V is equals to A sine 2 pi T upon T. So Y is LHS, which is equals to displacement. Displacement can be in terms of length. What about RHS? RHS, in RHS we have A sine 2 pi T upon T. So what is A? A is amplitude. Amplitude means this much length, this length. Okay, so this, how much length is this? Is this 5 meter? Is this 5 meter, 4 meter? How much it is in terms of meter, right? So this is your meters, means length. You are talking about length. This length, this much length. You subtract 0 and 5, so 5 meter length. Okay, so amplitude will be L. Fine. Sine is a function. 2 pi is constant, so it doesn't have any unit or dimension formula. Constant doesn't have anything. Here is t. So 2 pi T upon T. T is time. Small t is also time and capital T is also time. Remember, in this graph what we used to do, this is our t. Small t can be 0, 0.5, 0, anything. T can be anything, and this is capital T is perfect for one oscillation. One oscillation will give you capital T. Okay, so this is the difference. But since both are time, this is also time and this is also time. Okay, so time to time cancel out. It is constant, so it is angle. Okay, and we are left with length. So in LHS we have length, and RHS also length. LHS equals to RHS, that is L is equals to L. Sine equals to 2 pi. 2 pi equals to 180 degree. It doesn't have any unit. Angle doesn't have any unit. I mean, length to length cancel. Okay, it is angle. Angle has no dimensions. I mean to say, no unit. I mean to say angle don't have any dimensions like MLT form. It doesn't have any dimensions like M, L and T, or in 7 dimensions. Okay, so angle don't have dimension. It has a degree, radian. We used to from for example 2 pi. It means we are talking about radians. So it doesn't have dimensions like mass, length and time. Okay, so it is dimensionless quantity. We can say angle is dimensionless quantity. So we are just left with L. Let's talk about equation second. Equation second is y is equals to A sine Vt. Again, if you write it, y is again displacement, which is displacement has dimensions of L. Okay, what is A? Now RHS is A sine Vt. Or what is A? A is amplitude. Amplitude is L. Sine. V is velocity. Velocity is just we talked about velocity. Remember velocity. This is velocity. V is equals to LT minus 1. Remember, we just talked about V. Look, V is equals to displacement upon time. L upon T, that is V is equals to LT minus 1. So okay, LT minus 1 dimensions into, this is again time. Correct? Any problem? So T to T cancel, minus and plus 1 is 0. It will give you 0. So what are you left with? You are left with sine and L. Sine L. L is the dimension. But I just told you this must be some angle, and angle doesn't have dimensions. It is in radian, but it doesn't have dimensions like m, l, t form. So here we are getting L, we are getting sine in terms of dimension. It means this is wrong. So this formula is incorrect. This is wrong formula. Equation 2 is wrong and equation 1 is right. Check for density rho. What is density? Density is mass upon volume. Mass, that is m. Mass is denoted by m. What volume? Volume has dimensions L into L into L. So m upon L cube. Fine. What is R? R is radius. Radius is, suppose it's a circle. Circle has radius R. So remember, if your teacher used to say, what your teacher used to say, 5 centimeter radius, draw a circle of radius 5 centimeter. Since we are talking about SI unit, so it should be in terms of meter. Okay, only meter. If it is in centimeter, you have to convert it into meter. So meter means length. It means radius. Every time if it is in even centimeter, meter, you are talking about length dimension. Okay, so radius has dimension L, and since it is R cube, so cube both the sides. Okay, so L cube. Fine. What about surface tension? Surface tension means S. Students, don't worry about these formulas. I told you, as you go along with your physics chapters, by the time you will get all the formulas in your mind. So don't worry about it. Okay, surface tension is basically force per unit length. Force per unit length. So force, again, force is mass into acceleration and length in terms of L. Okay, so mass has dimension m. L is L upon T2 into L. Okay, so L to L cancels, so we just left with m t minus 2. When T2 goes to the numerator part, it will be t minus 2. So we have all the dimension formula of this physical quantity. So let's just put it in our equation 1, and let's see what we are getting right now. So K under root, big under root right now, rho is m upon L cube, rho is m upon L cube into R cube. R cube is L cube divided by what? S. S is the surface tension. So surface tension is m t minus 2. Can you see L to L cancel out? Okay, and then K under root m upon m t minus 2. Again, m to m cancel out. So K is equals to, when t goes up, it will be plus 2. T goes up, it will be plus 2. So this under root cancels out. So it is t. Since it is constant dimensionless quantity, dimensionless, so we just have t. Okay, and remember, in RHS also, in LHS also, we got seconds, that is t. So LHS equals to RHS, hence this formula is correct. Okay, so maybe some students may say, how many formulas we have? T equals to this, and in previous question we saw T in some other physical quantities. Look, we have so many physical quantities. We can express one quantity to other. We can have one formula. When we talk about surface tension, we used this formula of time. Why? Because at that time we have a drop. If you talk about drop, we what information of drop you have density, you have radius, you have surface tension. So in terms of this, we will get time. Ultimately, if you use this formula, we have time. So at the moment when we observe certain type of observation, we want that physical quantities which is easily observable, which we can calculate easily. So we just convert what information. So when I use rho, r, s, nobody can imagine that this will give me time. So there are so many drops of water. If it is falling down and I want to know the surface tension of each drop, it's so difficult for me. But I know each drop has some certain radius, I can find density, I can find surface tension of it, so I can easily find out time of it. So okay, that's why we need different formulas. Okay, so we have we did some numericals on error correction, that how dimension formula help us to correct our error. How this help us how to check the formula. This helps to check the formula whether this formula we are using is correct or not, whether it will go or not, whether it will go with our equation or not. Okay, so this is again one more use of dimension analysis. There are again in next part I will give you also this also one more use of dimension formula. Definitely we are going to do it, and we will do some numericals of it also. That is, we can make a formula with the help of dimension analysis. We can form a formula also. So in next part we will see that. So till then, thank you so much for watching. Khuda Hafiz.